Hi everyone, thank you for joining. My name is Shahir. I am the VP of Educational Technology at UTDL, and today I'll be presenting our ANSYS workshop series, starting with the Introduction to ANSYS Spaceclaim workshop. In this workshop, I'll be going over the general basics of ANSYS, getting your feet wet into the program and running through some beginner examples, as well as teaching you the importance of modeling and CAD simulations. This two-part ANSYS series will start off with modeling in this workshop and move on into simulations with our next workshop. So do look forward to that next week. Before I begin, I would just like to go through a bit of logistical things. First of all, UTDL as a club, we focus on providing educational workshops such as these to students regarding CAD software, such as ANSYS, Fusion 360, SolidWorks, etc. And we also host many competitions and grander annual design competitions to let students practice their CADing skills and their designing skills to actually produce some product or some design and compete with other students for a grand prize, whether it be some cash or some 3D printers, etc., etc. Every year we're trying to grow even more. And so this year we'll be having an even a greater year than last. Just some events that will be coming up this year. I'll actually be speaking about them later at the end of our workshop. So the next thing I want to talk about is the aid sheet, which I will be posting in the chat momentarily. With the aid sheet, what you can do is you can either use it as reference later on, or you can follow along right now during the workshop. I'll be posting it right now in a second. If you're not using UCF and you would like to download ANSYS onto your computer, I'll be having a slide dedicated to that later on. But if you want to go ahead and download ANSYS, then I'm also posting a link to download ANSYS right now. And lastly, I'm sure you've heard of it, but we are also hosting a raffle for every single workshop that we'll be doing for UTDL this year. It's a $25 Amazon gift card raffle. All you have to do is sign up to the link I'm pasting in the chat right now. There we go. Sign up using this link and you will be entered into the raffle, and the winner will be contacted separately and will be emailed the gift card. So I'll be turning on my camera for the majority of the workshop just so I can save some computer data. But yeah, I think that's all I need to say for now. So without further ado, let's get on with the workshop. So the purpose, like I said earlier on, was not to go into the details of Spaceclaim. Rather, it is to just get you familiarized with the overall ANSYS workspace so that you can go ahead and get started on your own little projects and get more in tune with the program on your own time. This workshop has been designed, like I said, not to only teach you about Spaceclaim, but the importance of CAD simulations and design. In this workshop, once I go over the motivation behind CAD, I'll be going over the basics of Spaceclaim. All I'll be doing is just opening up Spaceclaim on my screen and going through some of the basic features, and you can follow along as well. In this workshop, I'm also going to be making just a simple object, just going through it, going through the motions of making a simple object, using the skills that I taught beforehand, and then I'll go more into an in-depth exercise and making a sort of bracket using all the tools that are available to us in Spaceclaim. And then at the very end, I'll be open to answer any questions. So the motivation behind CAD, I like to think of it as visualizing it in sort of this diagram right here. You might be familiar with this diagram already. If you've gone through first year engineering through Praxis or ESP, you might recognize this as the engineering design process. And this middle circular area right here is the design space or the project space. And it is typically the space where you and your team spends time working on the project. So to get out of this space and to get to your quote unquote result, it could depend on a couple things. But for the sake of argument, I'm going to say that one of the biggest hurdles in getting to the results phase is getting a valuable result from your tests. So to expand on that a bit more, let's say a client needed to get their gardening supplies from point A to B. Just a quick example. So they want to get their gardening supplies from point A to B all in one go. And you and your team, after thinking about it for some time and listing some ideas, your team designs the first generation wheelbarrow. You know, as if, you know, the wheelbarrow was never invented before. Your team was the first people to invent it. So you build your first prototype of your wheelbarrow without really any modeling or anything, but you realize that the support of your wheelbarrow can barely support the weight of the wheelbarrow, let alone any additional loads. So it's practically useless. And you had no way of knowing while you're building up your first prototype. So what can you do? Well, you could, you know, buy or cut down some more wood, carve it up to make a new, better support, and then test that again. But what if that doesn't work? Then you go ahead and carve out some new wood and test that again, over and over and over again. But that ultimately results in a loss of time, money, energy, and admittedly, a lot of your sanity. I think you guys can agree on that. So this is where designing comes into phase, or computer automated design comes into play. Before you make your first prototype, your team can go into a CAD software to model and simulate the forces and supports on a wheelbarrow beforehand. Iteration through CAD is a lot easier and overall will help you get a better and a more pleasing design. So some examples of what you can do with CAD software and simulation is that you can model heat transfer simulations, like the picture on the left. You can also do impact analysis, which is very important, and is actually one of the things that we'll be going over in our next workshop next week. And you can also do fluid dynamics. So there's a whole wide range of simulation that you can perform to validate the results of your to validate your design before you move on into the designing phase or the physical creation phase. With CAD software, you not only improve your productivity and improve your design, but you can conversely, you can save time, money. You can simplify sharing between your teammates. You can just, send the file over to your teammates to have them work on it and send it back. Or with other programs such as Fusion 360, you can have it all in sort of one shared cloud. And lastly, CAD design, it saves your sanity. But there's a bit of an asterisk that I wanted to point out on saving your sanity, is because this only comes if you know how to use your CAD program effectively. If you're not adept or if you're not experienced with the CAD program, you might be pulling out more hairs than if you were to just physically design a wheelbarrow. So it's very important to learn the basics of computer automated design and simulation before you dive into the more advanced things, so that you have a solid foundation before you get into the heavier things. So before I just open up ANSYS on my screen and go through the basics, I just wanted to go through how you can download ANSYS for free on your own computer. I've put the link in the chat, but it's also on top of the screen right there. Once you open that link, you can just see the big yellow button to download ANSYS 2121 R2. I believe they have 2 new versions every year, and you're given a 1-year free license. So after 1 year, you're gonna have to reinstall ANSYS or update the license once a year. Once you have ANSYS installed, On EC, if you're on ECF, you can type in SCDM or Spaceclaim on your search bar to open it up, and it'll be the same thing on your personal computer as well. All right, just give me 1 second as I switch into my ANSYS screen. Okay, just want to check with the people here. Are you able to see my screen at all? The ANSYS Spaceclaim screen. Could you say something in the chat or give me a thumbs up? Yes, thank you. Thank you. All right, so this is the ANSYS Spaceclaim workspace. Before I even get started with messing around with any designs or anything, I just want to show you how you can change your units before you get started with your workspace, because units are pretty important, or else your design might be a whole magnitude too big before when you go to 3D print it or something. So all you have to do is take your cursor, go to the top left corner and click File, and down here click Spaceclaim Options. And once that loads up, if it ever loads up, why isn't it loading up? Oh, they're loaded up. All right, cool. You can go down to this left tab right here, click on Units, and you can go and switch between your units right here. Another useful feature, another option that you could or should tweak before you get started with your design is if you go down in units to the grid section, you can change the minor grid spacing. So right now it's defaulted to 1 millimeter, but if you're working with designs that might have, parts or components that are in the, I don't know, micrometer range, or, 1 or half millimeter range, then you can change your grid spacing to make it easier for you to model. Once you're done, you can click OK, and you'll be sent back over here. Okay, so the first thing, I guess I'd like to show you is how to make a basic shape. As you can see, once you load up ANSYS Spaceclaim, you're started off on the XZ plane in sketch mode, meaning that you can immediately go to this top tab right here, click on whatever tool you want, and sketch that tool onto the XZ plane. So what I'm going to do is I'm going to click on rectangle, just click on anywhere on my grid, click once, and before clicking again, what I'm actually going to do is, you can see one of my dimensions are highlighted in blue. So I'm going to go ahead and type out whatever dimension I want on that end, on the Z-axis, and then press Tab to switch to my other axis, and I'll make this, I don't know, 50. And then once I'm done, I can press Enter. And there I have my first shape. So now that I have my first shape, you'd want to make it into a 3D object. And the way you do that all is through extrusion. If you're familiar with SolidWorks or Autodesk Fusion 360, then it might be called extrude or something of that nature. In ANSYS or in Spaceclaim, it's called pull, right here in the edit tab right here. Every single extrude command, whether it be making fillets or all of that, which I'll be going over in this workshop, it is all through this pull command right here. So all you have to do is press pull, and then you'll be given the option to select your sketch. And what I'm going to do is I'm going to click once so that it's selected, and then I'm going to click and drag upwards so that I can create my 3D shape. Now, as you can see, as I let go, my dimension is highlighted, so I can go ahead and type in the dimension that I want. I'll say 15. Or actually, let me make it 30 there, and press Enter, and there I have my first shape. So now that I have my first shape, it's kind of at an awkward angle right now. It's not really centered in my screen. Kind of want to move around, look at it in a better angle. What you can do with your mouse is, if you press the middle mouse key and drag, you can orbit around your object like so. What you can also do is if you press Control and your middle mouse key, you can pan to sort of get it centered or move it over to the side if you want to. I have a mouse. I'm actually using a mouse that I don't usually use, but I have my daily mouse that has a very dysfunctional middle mouse button. So if your middle mouse button doesn't happen to work, then you can just go to the bottom right over here and see the options to pan and orbit like so. If you want to go and achieve default views, all you can do is just go to the top left corner and to the orient section and click once. By default, it will take you to the trimetric view. But if you click on this drop-down menu right here, you can switch between isometric, top, bottom, front, left, right, whatever. All of that is over here. And the home is, I believe, the trimetric view. Yeah. So these are just the default shapes. And if you want to, view it however you want, like so, then you can use your middle mouse key. And of course, zooming in and out is just scrolling your middle mouse key. So there are more, like I said earlier on, your extrusions. Do I see something in the chat? How would you switch from metric to imperial? So that was one of the earlier things that I went into. So if you just go to File, Spaceclaim Options, then in this left tab right here, you would see units, and right now it's defaulted to metric, but if you just click type, you can switch between metric to imperial, and even the lengthwise, so millimeters, centimeters, feet, yards, and et cetera, inches. I don't know imperial, I'm not American. All right, but yeah, I hope that answers your question. Let's see. So as I was saying before, your the extrudes that you can perform in Spaceclaim are all encompassed into the pull command. As I showed earlier, you can create a 3D extrude with the rectangular prism, but I'm about to showcase how you can create some cuts, some holes in your object using the same pull command. So first, what I'm going to do is I'm going to press Select, and I'm going to click this top half, this top shape of my my prism. And what this will do is that this will tell ANSYS that this is the plane that I want to sketch on next. So now that I've selected on this plane, I'm going to click on Circle. And as you can see, if I orbit around, a sketch plane has appeared on top of my my object. Let me just get back to a regular view and zoom in a bit. And all I'm going to do is I'm going to click once to center my circle, and then type in my dimension, let's say 15. Hopefully that's not too big, and press enter. That's good. And that creates a circle on top of my prism. And next, all I have to do is just press pull, click on my circle once, and just drag it all the way down to make my hole. So by default, ANSYS sort of already knew that I was going to cut, and not add material as I was going through my prism. If I were to go up, then ANSYS will know that I'm going to be adding material. If I go down, then ANSYS will know that I'll be cutting material. But if I want to make sure that no matter which way I'm going, I'll be cutting or adding material, I can go to this left tab right here. See if I can expand it a bit. So, and you can see that I can select cut to make sure that no matter which way I go, I'll be cutting. So if I had an object up here that I wanted to like cut into with the circle, I could do so. I just press cut, and then I can just move it up and down to cut into an object above. But for now, I'm just going to make a hole all the way through, and I'm going to orbit just to make sure that yes, it's gone all the way through. All right. So that's one extrude feature that you can perform. So the other extrude feature that you can perform through pull, can all be found either over here for edges or over here for sort of advanced pull features. So I'll go through them one by one. So I'll start with the edges first. What I'm going to do is I'm just going to select this edge and say I wanted to make a fillet. Well, ANSYS by default, when I press pull, you'll see the arrow now appears on the corner now. When I click and drag this arrow, you can see it automatically makes it a fillet, or a round is what ANSYS likes to call it. But if I focus, let me see if I can look at my left, like so. But say if I don't want a round, I want something sharper, I can go ahead and press pull and go to this left section right here in options. And as you can see a round has been selected. But I can just go ahead and click chamfer to get a sort of sharp edge, like so. And while I'm holding my mouse and dragging I can type in my dimension, let's say 10, and press enter to make it however, I guess, deep I want. And just to quickly go through the other pull options, there's this one where you can extrude the edge to create a surface. There's one to copy an edge, so it will basically take this line and just bring it down lower to the body. And another, I guess, useful one would be the pivot edge, where if I just click and drag one of these arrows, it will pivot the object like so. And I believe you can also do it on the other side, like so. This object looks really weird now, but it's just a demonstration, so no harm. So I'm gonna just Control Z these pivots because I want my top face to be a bit flat for my next example. Let's see. All right. So before I move on to the more advanced pull features or extrude features, I'd like to just go over a couple more ANSYS tools that you can use to help you with these extrude or pull features. The first thing that I want to go over is how you can move your object. Right now, as you can see, I've made my object based on 0, 0, 0. But if I want to say move my object around, all I have to do is press the move edit and then go to the structure tree right here and click on my solid like so. And as you can see, these arrows point up, letting me move my object any way I want, even tilt it along any of the axes however I want. Just Control Z all of that. Okay. The next, I guess, feature I wanted to show you is how you can make an additional plane. So by default, ANSYS gives you the XY, XZ, and YZ planes to play around with. But as you're building up a design on top of base parts, you'd probably want to create, reference planes or planes to build more objects off of. So all you have to do to create your own plane is to go to the Design tab, go to Create, and you can see the plane tool right here. All I have to do is just click once for a plane, and then I can click a reference surface to make it off of. So I'm just going to create a plane right here. And as you can see, on my structure tree, a new plane has been made. And just like a solid object, I can click on my plane and move it around however I want. Not really in the Z direction because the plane, and not really in that direction because it sort of encompasses both planes, but in the Y direction, it can move however far or however close you want. Right now, I'm fine with it being, let's say I'm fine with it being right here. Yeah, just because I feel like it. So now that you know how to create planes and how to move around your objects a bit, I'm going to go into a bit of the more advanced pull features. But I'm just going to quickly create a plane right here. And I'm going to offset that plane by moving it, let's say 30 millimeters away. Okay. And now I'm going to click on that plane and I'm just going to sketch a rectangle. Now to just get a better view, I'm going to just click on the Z axis And now I can go ahead and start sketching. And all my sketches, like as you can see right here, will be on this new plane that I made. So I'm just going to quickly create a rectangle, not really caring about the dimensions right now. And I'm going to click pull, click on my rectangle. And I'm going to go through some of these more advanced pull features. One of them is revolve, which you might have seen in SolidWorks. And all you have to, and it's pretty simple in ANSYS. Once you click on resolve, even ANSYS in the top left corner tells you the next step, what you should be doing. It tells you to select an axis to rotate about. And all I'm going to do is I'm just going to rotate along its own edge. And I'm just going to click and drag however many degrees I want, or if I want it all the way, I can just do it like so. Oh, whoops. Like so. And that's how you can utilize the revolve feature. Another more advanced feature that I kind of want to show everyone is the sweep feature. Sweep feature is extremely useful when creating pipe-like structures, maybe like twisting pipes or twisting tubes in SolidWorks. This is especially useful when you're modeling, when you're simulating thermal situations, so like the heat transfer in pipes or etc. So what I'm going to do quickly is just go to my z-axis, and I'm going to create a circle, let's say right here. And I'm not going to extrude it yet. I'm just going to see, I made it on the wrong plane, I believe. Yes, I did. I'm going to go and select this plane right here and create a circle. Like so. I don't know, I'll make it 10 millimeters in diameter. And let me just get a, no, I made it in the wrong plane again. What the heck? Sorry about that. Give me 1 second. Move this. End sketch editing. Select this plane, go to sketch mode, and yes, now it will be on this plane, which I can make a circle like so. 10 millimeter circle on the plane that I want. All right. Now to utilize the sweep feature, all you need is the sort of cross section of the shape that you want to extrude and a path that you want your shape to follow to create your extrusion. So if you recall, I made this horizontal plane right here, and I'm going to just end my sketch editing, click on this plane right here and enable sketch mode so that I can go to this plane. Look at it from the y-axis, or I guess a bit offset from it, so I can see my initial cross section. And now I'm going to start drawing my path or trajectory. All I'm going to do is just going to create a line starting from here, and I'll do something like this, maybe add a little bit of a curve like so, and then just finish it off with, let's say, a straight line, I guess, over here up to our object. And then all I have to do is just end, I believe you just end sketch editing, go to trimetric view, go to sketch, select our circle, press pull, click on sweep, and now it's going to tell you to pick a trajectory to sweep along. So all I'm going to do is click on my trajectory, press and hold Control, and click on the remaining pieces of my trajectory. And as you can see, I believe they're all being highlighted, very faint blue. And when I pull, you can see it follows along the path. And I think it fails close to, it fails at this curve, particularly because I think just the radius of the curve is a bit too small for the for this shape to be, for this to be produced. So what I'm going to try and do then, let's see, select. Dimension, go over here, and I'm going to try and so this right now is 10 millimeters, but when I just wanted to make sure that is right. Select, go to my plane, go to sketch mode. And I'll quickly show you maybe if it'll work if I create a smaller diameter circle and sketch editing. And this may or may not work, but I feel like it's worth trying it out. If I select my surface, go press pull, sweep, click along my trajectory like so. And there we go. The smaller radius, and ended up working a lot better. And now I have a very weird tube poking out of my relatively simple object. But that is the general basics of how you can go ahead and create this spline tool. It looked pretty cool while I was extruding it, and as you can tell, it can be very useful in certain CAD projects. So that's more or less all of the sort of pull or extrude features that I want to go over in this workshop. Now, all I want to do is just go over some more tools that you can use in Spaceclaim, and then I'm going to move on creating a example bracket object. So let me just get to the right view. And one feature that I want to go through is the split object feature. So I'm going to go ahead and just unhide this plane right here. So I have sort of a plane cutting through, I guess, both my tube and my simple object. And under the design tab, I'm going to go ahead and press split body. Now, split body, as you can see in the description right here, it first asks you to select a target object, which I'm going to just select our object right here. And then it requests a cutter plane. So before you can even split your body, you need a reference plane to cut with, which is why I had this plane right here. So I'm just going to click on this plane right here, or I can go to my structure tree, click on my plane like so. And as you can see, the bodies have been flipped, not flipped, split. And you can click on one of them to delete it, or you can just press escape to leave it as so and just have two separate bodies, as you can see here. Okay. I guess, next general feature that I want to go through in ANSYS Spaceclaim is how you can import additional objects. Say you're working with an assembly, or you're importing an object that your teammate made and you need to incorporate it into your design. What you can do is you can just go to the assembly tab and click on plus part file like so to import another geometry or even an image. The last sort of basic feature I wanted to go over in Spaceclaim is, you've seen it before, but I'm going to explain it now, is the measuring tool. So all you have to do is, I lost it. Yeah, sorry. It was in the detail. And if you go to the detail tab and you go to dimensions, you can go ahead and click on one edge to click on one edge and click on another to get a dimension, or you can just click on an edge like so to get there. So it doesn't seem to be working well right now, like so. There we go. You can get the dimensions right here. Or if you want to quickly measure, say an edge or a curve or whatnot, what you can do is you can go to the measure tab, click measure, and say if you want to measure the distance between these two edge lengths right here, all you have to do is click the edge one, hold control and click edge 2. As I can see, the distance between them is 25 millimeters. And you can see even more details down here. If I click on the surface, it will tell me the area. of this surface. And if I, highlighted the entire object, it'll give me the area. And I believe if you highlight the entire solid object, it can even give you the volume. So I believe if I go and click on solid, give you the area, and I believe if you click on mass properties, you'll be able to see the volume in millimeters cubed. Also surface area and other things that you might want to know about. So those are the basics of ANSYS Spaceclaim. I hope you learned a bit more on how to utilize ANSYS Spaceclaim. But what I'm going to do now is I'm going to go through constructing a basic bracket through this workshop, and that'll be just about it. So a quick and easy way is just to delete everything right here, just so I can have a fresh worksheet workspace to work on. And hopefully you guys are still able to see the my Spaceclaim screen, but I'm going to be switching back and forth between that and the drawing that I had in mind. To see the drawing of the bracket that I'm going to be making, feel free to open up the Spaceclaim 8 sheet, which will have the drawing right there. Actually, let me just take the time to repost some of the links because I believe there are some new people here. So I'll just post the links to everything in the chat right now. So the first link is to the ANSYS Spaceclaim sheet, and the second link will be to the Spaceclaim. Oh, whoops. First link will be to the Spaceclaim sheet, and the second link will be to the raffle. All right. So you can open up the HE and you'll be able to find the bracket that I'll be working on in this workshop. There's also going to be an additional, more advanced bracket for you to work on your own time. So let's get started with constructing this bracket. So as you can see in the HE, we're going to be working with a sort of rectangular bracket with a rib down the middle. So to work on that, actually, let me do something just in case you're not able to see. There, you should be able to see my entire screen right now, including Spaceclaim. So this is the bracket I'm going to be working on. It's a rectangular bracket with a sort of rib or a fin in the middle. You can see that there are different angles to help you visualize it a bit better as you model it in Spaceclaim. So what I'm going to do as my first step in Spaceclaim is click on rectangle, and right now ANSYS has me on, whoops. ANSYS wants, first I should select the axis I want to work on by clicking on sketch mode and clicking on the X axis, which is the axis I want to work on. And then I can go ahead and create a rectangle starting from the origin. And this rectangle will be a 100 by 64 by 22 rectangle or rectangular prism. So 100 by 64 by 22, no, 100 by 64. Try that again. 4 by 100 and press enter, and then quickly press pull and extrude this surface up by 22, and that will be the base of our bracket. In our drawing, you can see that part of the backside of our bracket is lifted up to a measurement of 75 minus 22, which I believe was 53 millimeters. So, and the depth of this sort of extrude right here is 15 millimeters. So I'm going to select, click on this surface, and press rectangle. Just click on the top view so I have an easier time sketching. And create a rectangle that's to the length of my bracket by 15 millimeters. I'm going to go ahead and pull this. I'll pull this by 53 millimeters, like so. Okay. The next thing that I want to do is to create these chamfers in this corner right here. So as you can see, they are 16 millimeter chamfers. So all I have to do is select I'm going to select both of my corners at the same time. So I've selected my first one right here. I'm going to orbit around. I'm going to press Control and hold it and click my second corner like so. So now both of my corners are selected. I'll press pull. And now when I pull on one edge, the other edge should also be extruded or chamfered as well. I'm going to go ahead and click on chamfer and click and drag down. And as I'm dragging down, I'm going to type in 16 millimeter so that it is the correct dimension. All right, let's go ahead and create the rib, and then I'll create this last little bit extrusion for last. So to create the rib, I'm going to select, let's say, this plane, and I'm going to draw a rectangle on it, and ANSYS has started a sketch plane on that, which is good. I'm going to look at it from the x-axis, and just to make it a bit easier for myself, what I'm going to do is I'm going to draw a construction line starting from the bottom, 6 millimeters out this way, and then create a rectangle that is going to be 12 in length and 40 in height. 12 in length and 40 in height, like so. Just get a nice view on that. And now I'm just going to pull on this rectangle by 70 millimeters. And the last step to make this a rib, or I guess a fin, is to select this edge right here, press pull, and now I'm going to use the pivot edge feature to pull it all the way down, like so. Cool. So we're almost done with our bracket. The last bit is making this extrusion right here. As you can see, the dimensions for this is a bit complicated. It's not too straightforward. You're going to have to sort of interpret the dimensions given here first before you can go ahead and make your extrude. For example, you don't know the dimension of this bottom cut right here. You only know the 30 millimeters up top. So that's like some drawings might not give you all the information that you need to complete the drawing. But you should have enough dimensions to hopefully complete it, to create your design. So the first thing I'm going to do is the same thing as like before. I'm going to create first I should select my face and then create a construction line so that my construction plane, my sketch plane is on that surface. I'm going to go to the bottom right here. I'm going to create, I believe, 15 millimeters this way. And 12 millimeters up above. Gonna make sure. Okay, 12 meters up above. And then I can go ahead and make my 30 millimeter line like so. There are multiple ways you can tackle this, of course. I'm just going about the way that how I would do it. But if you have a more efficient way or a way that's more suited to your style, then you can go ahead and do it your way. But I have my 30 millimeter line like so. And now I'm told here that the angle between my top line and I guess the bottom line that's over here is going to be 60 degrees. So I'm going to just click here and let's see if it's going to be I believe 30 degrees based on this dimension. based on where I'm starting over here. But I believe it's because it's on reference to this axis over here. But if it was in reference to this bottom axis right here, then it would be 60 degrees. If I do the same thing over like so, as you can see, I'm able to have this line at a 60-degree angle like so, and then I can create the shape so that it's fully enclosed and I can use it to extrude. I'm going to use the pull feature once again and press pull. Zoom out a bit for this. And before I pull, I'm going to just make sure I have cut selected, and I can just pull through the entirety of the shape like so to complete it. Now, all I have to do is just get rid of my curves, which are all just construction lines now. And that is the bracket, more or less. What you can also do to add some more practice to this bracket is by selecting these edges like so. If you want to, I guess, add some more flair to your bracket for, I don't know, whatever reason, you can click on these corners right here. You can press pull, and you can go and just click on, make sure it's selected on round, and just pull these out by, let's say, 10 millimeters to have these ribs sort of filleted like so. So that is the bracket exercise that I wanted to go over. Just gonna start presenting. So I hope you've learned, I guess, how to go through modeling sort of a very simple design on ANSYS Spaceclaim, and I hope you take your own time to model your own designs. Here's another example of another bracket that you can do on your own time. It's only one drawing and looks pretty messy right now, but as you work on it, I'm sure you'll be able to understand and get more accustomed to it. So that will be the end of my workshop. Let me see if I can turn my camera back on. That will be the end of my workshop. I hope you all enjoyed and learned something new today. Next week, we'll be having the second part of our ANSYS series, which will be going into simulations using ANSYS. So please watch out for that workshop, and feel free to participate. We'll be going over static simulations, thermal simulations, and explicit dynamics. So if you want to learn more about the simulations or the general basis of simulations, then feel free to drop in. Coming this November, during our reading week, we'll also be hosting a joint mini competition alongside the Applied Architectural Design team from the Daniels faculty at U of T. It's a joint competition where students will be teaming up with architecture students to create a transit design that can help improve traffic flow across the U of T campus. If any of that sounds interesting to you, then watch out for our Facebook and Instagram pages for details on that event. And of course, we have our annual design-a-thon next year in February. So please be sure to watch out for that. And I would really do look forward to seeing you all attend that event. With that out of the way, if there are no questions in the chat, I'd be very happy to say goodbye to all of you now. I hope you all learned something new in this workshop, and I hope you all have a very, very good evening. Thank you so much for joining. No problem, Anna. If there are no questions, I'll be ending the meeting just in a bit.